Hello everyone, welcome to my channel. Today I will discuss about the basic concept of periodic table. This is the second lesson of this topic. If you have not watched the previous lesson, then I will share the link in the description box. You can go and watch that video. So let's start the lesson. This is the picture of the periodic table. Now in the previous video, I have told you about the transition elements. Those are the elements present in the middle of the periodic table from the group 3 to group 12. Now there are few elements who are known as inner transition elements. These elements are present inside these transition elements. Two series are present, one lanthanide, another actinide. Lanthanide series is present in period 6, which starts just after the element lanthanum. Lanthanum, though it is written here, but in periodic table it is present in this place. Okay, so as this series starts just after the element lanthanum, that's why the series is named lanthanide. And actinide series is present in period 7. Now this actinide series starts after the element actinium, though it is present here, but in the periodic table it is placed in this position. Okay, so as this series starts after the element actinium, that's why the name of the series is actinide. The first element of lanthanide series is cerium and the last element is lutetium. The first element of actinide series is thorium and the last element is lawrencium. You have to remember these four elements. Why? Because often question comes, what is the first and the last element of these two series? Then you have to write the names of these four elements. Okay. Now, the elements who are present in group 1, they are known as alkali metals. Why they are called alkali metals? Because these elements, when they react with water, they form alkalis. What are alkalis? Alkalis are the bases which are soluble in water. So as they form alkalis, these elements which are present in group 1, they are called alkali metals. Clear? The elements which are present in group 2, these elements are called alkaline earth metals. These elements, when they react with water, they form alkaline solutions. That means they form hydroxides which are alkaline in nature. That's why these elements are called alkaline earth metals. Here alkaline earth means the hydroxides which are alkaline in nature. That's why these elements are called alkaline earth metals. Again, the elements which are present in group 17, these elements are called halogens. Why they are called so? In Greek, the word halogen means salt producing. Now these elements are non-metallic in nature. When these non-metals react with metals, then they form salts. As these elements form salts, that's why they are named as halogens. Because halogen in Greek means salt producing. That's why these elements are called halogens. Clear? Now, we will study some basic properties of alkali metals and halogens. What are the common elements present in group 1? Like lithium, sodium, potassium, etc. And in group 17, fluorine, chlorine, bromine, iodine, all these elements are present. Now both alkali metals and halogens, they are univalent. That means they have a valency 1. They have a valency of 1. Now the group number, as I have told you in my previous video, group number signifies the number of electrons that are present in energy shells of an atom. So alkali metals, in case of these elements, only one electron will be present. Why? Because they are present in group 1. So that's why only one electron will be present in their valence shell. And in case of halogens, as they are present in group 17, so only 7 valence electrons will be present in their valence shell, right? Now you can have a question in your mind that if alkali metals have only 1 electron in its valence shell and if halogens have only 7 electrons in its valence shell, then how come they both are univalent? They both have one valency. How is this possible? See, let's take an example. Let's take an element from group 1, sodium. Okay? And let's take another element from group 17, chlorine. Electronic configuration of sodium is 281. Electronic configuration of chlorine is 287. Okay. Now, sodium has 1 electron in its valence shell. So as to achieve octet, octet means so as to have 8 electrons in its valence shell, it should donate 1 electron. If sodium donates this electron, then it will have 8 electrons in its valence shell. So, sodium will donate 1 electron to achieve octet. As sodium is donating 1 electron to achieve octet, that's why its valency is 1. And in case of chlorine, 7 electrons are present in its valence shell. It should also has to achieve the octet configuration. Now, the easiest way for chlorine to achieve octet configuration is to gain 1 electron, because 7 plus 1 is 8. So, chlorine will basically accept 1 electron so as to achieve octet, right? So as chlorine is accepting 1 electron, that's why its valency is also 1. So I think now it's clear why both alkali metals and halogens have valency 1. Okay. Now both the halogens and alkali metals are highly reactive, but alkali metals are electropositive, whereas halogens are electronegative. Why? See, in my previous video, I have already told you that the elements which are present in the left of periodic table, they are metallic. That means they are metals. And the elements present at the right of the periodic table, they are non-metals. Right? Metals means they are electropositive. Non-metals means they are electronegative. Alkali metals are present at the left of the periodic table. That's why they are metals or electropositive. And halogens are present at the right of the periodic table. That's why they are electronegative or non-metals. Alkali metals are usually soft. They are white solids who can be cut with knife. But halogens show different states of matter. Like fluorine and chlorine are gases. Bromine is liquid and iodine is solid at room temperature. So different states of matter are represented by halogens. Some are gases, some is liquid, and some is iodine. Solid, as iodine is solid at room temperature. Clear? Now, moreover, alkali metals are good conductors of electricity and heat, but halogens are bad conductors of electricity and heat. Alkali metals are strong reducing agents and halogens are strong oxidizing agents. What is the meaning of this term? Strong reducing agents means alkali metals donate electrons. They are electron donors. And strong oxidizing agents means halogens are electron acceptors. They accept electrons. If you can remember my example, the sodium is donating an electron to achieve octet, right? So that's why it is a strong reducing agent. Whereas chlorine is accepting 1 electron so as to achieve octet. So that's why it is a strong oxidizing agent. Clear? And when alkali metals react with non-metals, they form electrovalent compounds. And when halogens react with non-metals, they form covalent compounds. Let's see what is an electrovalent compound and what is an covalent compound. First, when alkali metals like sodium reacts with a non-metal like chlorine, they both form a electrovalent compound. Sodium is 281, chlorine is 287. So as to achieve octet, sodium should give 1 electron to chlorine, and so as to achieve octet, chlorine should accept 1 electron from sodium, right? So here, to achieve octet, both of them, what are they doing? Sodium is giving one electron, that means it is donating an electron, and chlorine is accepting that electron from sodium. Clear? So it is basically the give and take policy. Sodium is giving and chlorine is taking. Clear? So this is the electrovalent compound. On the other hand, what is covalent compound? Let's take an example of HCl. Hydrogen and chlorine. Hydrogen, its configuration, what it's 1. Chlorine is 2H7. Now, so as to achieve duplet, that means hydrogen should have 2 electrons in its valence shell. So as to achieve duplet, it should have 1 more electron, right? And chlorine is having 7 electron in its valence shell. So it should have another electron to achieve 8 electrons, that means octet. Now if hydrogen donates this electron, then it will be 0. Now no elements exist in 0 electronic configuration. So what will happen? They both will share these 2 electrons in its valence shell. Now hydrogen is having 2 electrons, duplet achieved by hydrogen, and chlorine also has 7 and 8. Octet is achieved by chlorine, right? So this type of compounds, when there is sharing of electrons, those compounds are called covalent compounds. Clear? Now, this is all about the alkali metals and halogens, right? Next comes, what is the periodicity in properties means? The properties which appear at regular intervals in the periodic table are called periodic properties, and the phenomenon is known as periodicity of elements. This means that when elements are arranged in increasing order of their atomic numbers in the periodic table, then there is an occurrence of characteristic properties of the elements at definite intervals. That means similar properties will appear at regular intervals. This happens because after a definite interval, similar valence shell electronic configuration occurs. Let's take an example. Okay. Now take an example of fluorine and chlorine. There is a gap between fluorine and chlorine. After fluorine, if we count from 1 to 8, then after fluorine, the 8th element will be chlorine. Okay. Now the electronic configuration of fluorine is 287. Sorry, it's 27. It's 27. The electronic configuration of fluorine is 27. And the electronic configuration of chlorine is 287. So, in the valence shell, both fluorine and chlorine, they both have 7 electrons. Now, as they have a similar kind of electronic configuration, so they will also share some similar properties. This is known as the periodicity in properties. Right? Now, there are certain properties in which periodicity can be observed. First is atomic radii. Atomic radius, in plural we say radii. Then it's ionization potential, electron affinity, electronegativity, non-metallic and metallic character. Now first comes to atomic radius. What is atomic radius? Atomic radius is the distance between the center of the nucleus and the outermost shell of the atom. Suppose this is an atom. Okay. This is the nucleus. So it is the distance between the center of the nucleus and the outermost shell of an atom. This distance we will represent as atomic radius. Clear? Next property is ionization potential. What is an ionization potential? Suppose there is an atom M, okay, and it is donating one electron. When it donates one electron, then it will become unipositive, right? This is an unipositive. This atom is donating one electron. This electron is removing. This electron has been removed from this atom, and it has become unipositive now. Now, ionization potential is the minimum amount of energy that is required to remove an electron from its outermost shell. Right? So, the energy that has been required, or that is required so as to remove this particular electron from its valence shell, from this atom, that is the ionization potential. Next is electron affinity. Now, if this M atom is accepting one electron, when an electron gets added to that atom, then it will become uninegative. Then also some energy will be released. Some energy will be released in this reaction. That energy is electron affinity. So electron affinity is the amount of energy that will be released when an atom will accept an electron. Clear? To form an anion. This is basically an anion, uninegative. Right? Clear? Now next is electronegativity. What is electronegativity? Electronegativity is the tendency of an atom to attract electrons to itself when it gets combined in an atom. Okay? When it is combined in a compound, then the tendency of that atom to attract electrons to itself is known as electronegativity. Let's take two examples. One of NaCl, which I have already shown. What's happening? It's 281, it's 287, right? So here sodium is giving one electron and chlorine is accepting one electron. So they differ widely in electronegativity. Why? Because here sodium is donating an electron and chlorine is taking one electron. So in this case, the bond that will form between them is ionic in nature. While on the other hand, if we take another example like formation of the chlorine molecule, Cl2, 2 chlorine. Chlorine is 287. This is also the same, the electronic configuration for both the chlorine. Now, what they will do, they both have 7 electrons in its valence shell, right? Now, they will require 1 electron to complete their octet configuration. So, they will share the electrons. So, the both of the chlorine, it's sharing electron. That's why they have nearly similar electronegativities, because they both are sharing 1 electron to complete their octet. In this case, the bond that will form is covalent. Clear? Now, next character is non-metallic and metallic character. What is non-metal? A non-metal means when it will gain 1 or more electrons. Suppose M is an atom and it is gaining 1 electron to form an anion. Then we will call it as non-metal. And what is a metal? If M is an atom and if it is losing 1 or more electrons to become a cation, then we will call it as metal. Clear? This is the metallic and non-metallic character. And all these characters show periodicity. Okay. So, this is all about this lesson. I think the basic concept is clear to you all now. I will upload other lessons on this topic very soon. Till then, stay tuned to my channel, and if you think my videos are informative and helpful, then please like and share my videos, and don't forget to subscribe to my channel. Thank you for watching the video.